Hello children, welcome to Spark Physics by ASHISH Sharma sir. I am back with a new video under your unit electromagnetic induction. The topic is induction. Here, first we will understand what is the meaning of induction. Then you will find coefficient of induction. Then you will find there are two types, self-induction and mutual induction. We will be finding what are these and we will be deriving the relations for self-inductance and mutual inductance. Okay, so let's begin with the induction. Induction word itself says that something is going to be generated, induced. And what is that? We have studied from the beginning in the previous videos also under this electromagnetic induction itself, that whenever there is change in the magnetic flux, current is induced. The same thing, induction is nothing but the phenomena of generation of current in the coil due to change in the flux. Here change we will be dealing with magnetic flux. Okay. Now when it comes to self-induction, you will find it is the property. See the word you should not confuse induction, inductance. जैसे हमने पढ़ा है resistance and resistor. So resistor is the device, okay, and resistance is its property. Okay. Similarly, inductor is the device, inductance is its property. And when we talk about self-induction, it is the property of the circuit by virtue of which it tends to oppose the change in the strength of the current through it by inducing an EMF in itself. That means whenever there is change in the magnetic flux, current will be induced, but it will be such that the EMF will be induced in itself. उसी में ही EMF induced होगा, which will be opposing the current, strength of the current in the circuit, right? That is called self-induction. If we take a coil, suppose, तो इस coil में जो current flow होगा, उस current flow होने की वजह से magnetic flux change होगा. Magnetic flux change होगा, तो it will be inducing the current. लेकिन उसका direction क्या होगा? What Lenz's law says? That it will oppose the strength of the current or the growth of the current, right? So what happens here? I have drawn the diagram. You see, we have taken a coil, battery is connected with it. There is a tapping key. Tapping key, what it does? When you tap it, you will find the circuit will be closed and the current, battery current will start flowing here. When the battery current flows, the current goes through the coil, linked with the coil, there is change in the flux. What happens? Initially there is no current. When you tap this key, the current starts from 0 to maximum value, right? So that means the flux change will be from 0 to maximum value. So momentary change of the flux. So because of that, there will be induced current in this coil. So the direction of this induced current will be opposite to the battery current. Now, in the second diagram, if you see, we are opening this key, tapping key. What will happen? The current will change from maximum to minimum value, 0. When the current changes from maximum to minimum, the flux linked with the coil will change from maximum to minimum. Current will induce. Current यहाँ से जो बैटरी करंट जा रहा है वो कम जा रहा है, मैक्सिमम से मिनिमम हुआ, तो ऑब्वियसली द इंड्यूस्ड करंट उसका अपोज करने वाला है. क्यों? बिकॉज द करंट इज डिक्रीजिंग, सो इट विल ट्राई टू मैक्सिमाइज इट. सो मैक्सिमाइज करने के लिए it will be inducing the current in the same direction so that it will be getting added. When we talk about this induced current, it is opposing. When we are saying this is battery current in the direct in the circuit and you will find the current is induced in the opposite direction, तो इसका मतलब जो current यहाँ से I यदि जा रहा था तो यहाँ से I नहीं मिलेगा क्या? मिलेगा, because the external agency which is providing the current will be doing some work that we will also be calculating. Okay. Let's see now what is coefficient of self-induction. That is also called self-inductance or simply the inductance. At any instant we find that the magnetic flux is proportional to current. जो phi है that is proportional to current I. When there is a proportionality sign, there will be some proportionality constant, that is L, and this L is called coefficient of self-induction or the self-inductance or simply the inductance. Okay, we find this L depends on three things mainly: number of turns in the coil, area of the cross section of the coil, and nature of the material of the core on which this coil is wound. Now we will define this L, and this can be defined in two ways. So we have got phi is equal to Li. If we take this I as 1, so what we will get? Phi is equal to L. This phi is equal to L. That means this numerically, this self-inductance or the coefficient of self-induction is of a coil is numerically equal to the magnetic flux linked with the coil when a unit current flows through it. We have taken current 1, so obviously we will be taking when a unit current flows through it. Okay. Now another formula we have from Faraday's laws, that E is equal to minus d phi by dt, और phi हमको कितना मिल गया? Li from here. So this will give you E is equal to minus L di by dt. So di by dt equal to 1. If we take from here, if you take this di by dt 1, you will be getting E is equal to minus L. This will give you L is equal to minus E. So from here we can again define coefficient of self induction of the coil is equal to the EMF induced. देख लीजिए, EMF induced in the coil. Condition क्या है? Rate of flow of the current through the coil is unity. Now we have units of inductance, that is L. In SI system it is Henry. Letter is, symbol is H. And we know L is equal to E upon di by dt. Finding the unit, we are not taking minus sign. Okay. So 1 Henry will be equal to EMF कैसा करेंगे? 1 volt upon di by dt, current upon time, 1 ampere upon 1 second. So this will give you 1 volt second per ampere, and this is nothing but Weber. So we can have 1 Weber per ampere. So from here we can define 1 Henry, right? It is the self inductance of the coil when EMF generated is 1 volt, when the current flows through the rate of, or current changes with the rate of 1 ampere per second. Okay. In CGS system you will find it is measured in EMU, and the relation, or the ab Henry, and the relation is 1 Henry is equal to 10 to the power 9 EMU of the inductance. Now we have dimensions. Learn कीजिए, पूछे भी जाते हैं ये dimensions. L is equal to E upon di by dt. We have E, that is potential, हमको मालूम है ml square t minus 3 a minus 1, di by dt A upon t minus 1. So a t minus 1. Solve this, you will get m1 L square. This will go up, so it will be t minus 2 and a minus 2. Now we will be seeing the self inductance of the long solenoid. अभी हमने क्या देखा कि what is induction, what is self inductance, what is self induction, coefficient of self induction, and now we will find out the self inductance of the long solenoid. For that we have taken L, the length of the solenoid, R, the radius of the solenoid, which is less than the length, N is number of turns per unit length of the solenoid. Okay, and at any instant we know that the magnetic field due to the solenoid is given by B is equal to mu naught Ni. Okay, so what will be the magnetic flux linked with the coil, or linked with the each turn? First we will be finding the magnetic flux linked with each turn, say phi, or we can just write equal to how much? We know it is B into A, where A is area of the solenoid, or we can say the cross sectional area. So this is equal to mu naught Ni A. This is magnetic flux linked with the each solenoid. So what will be the magnetic flux linked with the entire solenoid? Therefore the magnetic flux linked with entire solenoid will be equal to, say, phi equal to mu naught Nia into N into L. So when we are finding for entire solenoid, we need to multiply it by total number of turns. Total number of turns कितनी होंगी? N into L, because N is number of turns per unit length. So we are getting phi is equal to, you see here, mu naught n square I into A into L. Okay, this is the magnetic flux. Now we will finding the self-inductance. Since L is equal to phi upon current, so therefore L will be equal to mu naught n square AL. I will cancel. This is the self-inductance of the solenoid, and we know n is number of turns per unit length. If we substitute this value, if n is total number of turns, total number of turns of the solenoid, क्या करेंगे? Substitute L is equal to mu naught n square AL upon L square. This will cancel, so we are left with mu naught n square A upon L. This is the self-inductance of the solenoid. If the coil is wound over the material of high magnetic permeability mu r, so simply we will be multiplying by mu r and we will get L is equal to mu r mu naught n square A by L. Now we will see how much work is done to overcome that opposition. That means how much energy is stored in the inductor. That can be calculated. Let's see how we will calculate. We have seen that when the current is induced in the coil, which opposes the growth of the current, that is, since it is opposing, so we also called as back EMF, and it plays the roles of inertia. Inertia का role play करता है, और that means when it is opposing, inertia का role play कर रहा है. इसका मतलब some work has to be done so that there is continuous flow of the current. There is no opposition. Current कम नहीं होना चाहिए उस सर्किट में. तो कैसे? So that work done by the external source is stored as potential energy, magnetic potential energy of the inductor. Getting my point? Which we need to calculate. कौन सी एनर्जी हमको कैलकुलेट करना है? जो वर्क डन हमको करना पड़ रहा है अगेंस्ट दैट बैक EMF for the constant flow of the current, that is stored as magnetic potential energy of the inductor. So suppose, and we know the rate of work done. What is the formula? We can write dW upon dt, rate of work done, is power, which we can write E into I. We will take magnitude. For E we can write L di by dt. I, this we can write L I di by dt. लिख सकते हैं. That means which will give you dW is equal to Li di. Suppose the current increases from 0 to I, so total work done will be, we will be integrating this dW, which will give you W equal to integration from 0 to I Li di, and L is constant, integrate I, it will give you I square by 2. So therefore we are getting work is equal to half Li square. हमको half Li square मिला, और ये जो वर्क डन है this is stored as magnetic potential energy in the inductor. Okay, I hope it is clear now कि हमने क्या किया. We have calculated rate of work done. From there we have integrated and got the work done. Okay, thank you for watching this video till the end. Important concept hai. In the next video we will be coming with mutual induction. Okay, don't forget to see that video. And what about this? Don't forget to like, share and subscribe. Comment bhi karna hai, spread bhi karna hai, please. Thank you once again.